वेलकम इन अनदर वीडियो ऑफ कंप्यूटर नेटवर्किंग स्टूडेंट। लास्ट लेक्चर में हमने सर्किट स्विचिंग का डिटेल स्टडी किया था। तो आज के इस वीडियो लेक्चर में हम सेकंड जो स्विचिंग मेथड है दैट इज़ पैकेट स्विचिंग एंड मैसेज स्विचिंग, तो उसका हम डिटेल स्टडी करेंगे। तो शुरू करते हैं आज का वीडियो। तो सेकंड टाइप ऑफ स्विचिंग टेक्निक इज कॉल्ड एज अ पैकेट स्विचिंग। सो इन पैकेट स्विचिंग इज़ अ कनेक्शन लेस नेटवर्क स्विचिंग टेक्निक्स। ठीक है, तो जिस तरह से आपका सर्किट स्विचिंग इज़ अ कनेक्शन ओरिएंटेड स्विचिंग टेक्निक्स, तो उसके अपोजिट ये पैकेट स्विचिंग है। सो पैकेट स्विचिंग इज़ अ कनेक्शन लेस नेटवर्किंग switching techniques in which the message is divided and grouped into the number of units called as the packets, and that are individually routed from source to the destination. So that is a simple working principle of this packet switching network. So in that the large message is formed into the group of number of units, means it is divided into the number of units, that is also called as a packets, and these packets are transmitted from sender towards the receiver, and it has a different paths from this sender to the receiver. So that type of switching techniques is called as a packet switching. So in packet switching there is no need to establish a dedicated circuit connection between sender and receiver. ठीक है, तो जिस तरह से सर्किट स्विचिंग में जो फर्स्ट फेज है उसमें there is a establishment of connection between sender and receiver, but in case of this packet switching there is no need to establish a connection between sender and receiver. Then we'll see the process of packet switching with the help of one example. So here we consider a sender, which is nothing but the transmitter who wants to send the data towards the receiver. So that is Rx. Or suppose we can take this machine A that will send the data to the machine B, and there are different paths in between this sender and receiver, or in machine A and machine B. So these are the different paths available to send this packet. So we already know that the large message can be split up into the smaller packets in packet switching, and these number of packets will be transmitted from senders towards the receiver, and they are travel through the different paths. So here we take these 4 packets, that is A, B, C, D, and these packets are transmitted from the senders towards the receiver. So each packet in a packet switching technique has 2 parts, a header and a payload. So we already know that the packet consists of a header portion and a payload portion. So that payload is nothing but the actual data or bits or the information to be transmitted, and the header packets consists of the source and destination IP address. Okay, so header में आपका source and destination का IP address होता है, एंड पेलोड में एक्चुअल जो डेटा है या डेटा बिट्स है वो आपका पेलोड में होता है। उस तरह से द हेडर कंटेन्स द एड्रेसिंग इंफॉर्मेशन ऑफ द पैकेट, मीन्स सेंडर एंड सोर्स एंड डेस्टिनेशन का आईपी एड्रेस, एंड इट इज़ यूज टू बाय द इंटरमीडिएट राउटर्स टू डायरेक्ट इट टूवर्ड द डेस्टिनेशन. सो व्हेन दिस पैकेट, सपोज ए पैकेट विल बी सेंड, इट कंसिस्ट ऑफ द सेंडर आईपी एड्रेस, ठीक है, मीन्स किसने सेंड किया है, एंड डेस्टिनेशन आईपी एड्रेस, मीन्स कहाँ पे उसको रूट करना है. व्हेन दिस पैकेट विल बी ट्रांसमिटेड इन अ नेटवर्क, सो देर आर डिफरेंट nodes are there. So these are the circle are nothing but the intermediate node. So each node will be fetch this source and destination IP address and route that packets towards the different routes, means towards the receiver. So the payload carries the actual data, and we already know that the payload consists of the actual number of bits that can be transmitted. So a packet is transmitted as soon as it is available in a node. So based upon its header information, the packets of message are not routed via the same path. So these packets are traveled towards the receiver via the different paths that can be available. So suppose this A can be travel like that. First one, it will go to the first intermediate node, then second, then it will rotate to the third, then fourth, and then fifth, like that. And this B, that is second packet, will be transmitted from sender to receiver through the different path. ठीक है, तो यहाँ पे मैं रेड लाइन से मार्क कर रहा हूँ. ठीक है, सो दैट इज़ द पाथ फॉर द B packet. Third packet is a C that can be transmitted through the different nodes towards the receiver, like that. So the packets in the message arrive in the destination out of order. ठीक है, तो इसकी वजह से क्या होगा कि ये जो पैकेट यहाँ से ट्रांसमिट हो रहे हैं फ्रॉम सेंडर एंड, सो दैट कैन बी a b c d. So it can travel through the different path in a network or in an intermediate node. So that can be received at the receiver that is out of order. Means suppose A will be transmitted first, but it will receive the late in the receiver, and the B will be receive earlier because B will be transmitted or travel through a shortcut path. So like that. So at the receiver end, these packets are again serially maintained. So it is a responsibility of the destination to reorder these packets in order to retrieve the original message. तो रिसीवर का काम जो है वो ये जो जिस ऑर्डर से सेंड हुए हैं, ठीक है, उसी ऑर्डर में यहाँ पे इसको सीरियली अरेंज करना है. ठीक है, सो दैट द ओरिजिनल मैसेज विल बी रिकवर विच कैन बी सेंडेड बाय दिस सेंडर. So the process is diagrammatically represented in the following figure. Okay, तो यहाँ पे हमने एग्जाम्पल लिया है. ठीक है, here the message comprises the 4 packets which are ABCD, which is sent by the sender and which may follow the different routes from the sender towards the receiver, like A, B, C and D. And these packets will be arrive at the receiver that is out of order, and the receiver work is to rearrange these different packets into the same order which can be sended by this sender, means reorder, and the original message will be recovered. So that is the simply working process of this packet switching technique. So at the receiver end, again it will be arranged in a serial order like A, B, C and then D, and the original message is recovered at the receiver end. Then we'll see some of the advantages and disadvantages of this packet switching. So first we'll see the advantages. So first advantage is delay in delivery of packets is less since packets are sent as soon as they are available. ठीक है, तो सेंडर से जो पैकेट ट्रांसमिट होंगे टुवर्ड द रिसीवर, सो द delay in the delivery of packets is less. As soon as these paths are free, so the packet will be transmitted immediately. Again the next packet will be transmitted easily when these paths are free. So this is one of the advantage of this packet switching. Second, switching devices doesn't require a massive storage since they don't have to store the entire message before forwarding them to the next node. तो यहाँ पे जो intermediate node यहाँ पे यूज़ किया है, they doesn't require to store this message. They have to only simply receive this packet and check its header, means source and destination address, and forward that packet towards the next node. So that is also one of the advantage. Then third, data delivery can continue even if some part of the network faces link failure. Packet can be routed via other paths. So suppose these intermediate node are, suppose one of these intermediate node are fail, so at that time the packet will take the or choose the another path. Suppose in this example, this third node will be not in service, okay, so or it will be a fail. So at that time this packet A will be transmitted from 1 to 2 and then 2 to 3 by like this route, and it will goes to the destination like that. Next advantage is it allows the simultaneous usage of the same channel by the multiple user. Means the same channel can be, or same transmission media can be used by the multiple users to send the data. Next, it ensures the better bandwidth usage as the number of packets from multiple sources can be transferred via the same link. ठीक है, means at a time multiple users can communicate with the other. Means at the same time the number of devices will transmit the data, and these packets will be transmitted through the different paths towards the receiver. So multitasking or multiple packets can be sent at the same time in the same link. So that is also advantage of this packet switching. So these are the main advantages of this packet switching. Then we'll see some of the disadvantages of this packet switching. So first disadvantage is they are unsuitable for application that cannot afford delays in communication like high quality वॉइस कॉल. ठीक है, तो हाई क्वालिटी वॉइस कॉल में जहाँ पे डिले अफोर्ड नहीं है, सो इन दैट कंडीशन दिस पैकेट स्विचिंग इज़ नॉट यूज, बिकॉज हमने यहाँ पे एग्जांपल में देखा कि डिफरेंट पैकेट्स टेक्स द डिफरेंट पाथ्स, सो द रिसीवर will have to rearrange this packet, so it requires some time. So due to that there is a mismatch in the communication or in the voice calls. That's why this packet switching is not used in high quality voice calls. Second disadvantage is packet switching requires the high installation cost. So the installation cost for this packet switching networks, so that is high as compared to the circuit and the massive switching. Third one, they requires the complex protocols for the delivery. The protocols which are used for this transmission of packets to the different paths, so that is also complex process. Next one, network problems may introduce errors in the packets, delay in delivery of packets, or loss of packets. If not properly handled, this may lead to a loss of critical information. ठीक है, so due to the network problems the errors will be introduced in sending this packet, or there is a delay in delivery of packets, or loss of packets in the network. So if it is not handled properly, so there is a loss of the critical information. So these are the some of the disadvantages of this packet switching. Then we'll see the third type of switching techniques, which is called as a massive switching. So massive switching is a connectionless network switching technique. So massive switching technique जो है वो connectionless network switching techniques है, where the entire message is routed from source node to the destination node. तो इसमें जो मैसेज या डेटा ट्रांसफ़र होता है that is routed from the source towards the destination node, one hop at a time. So then we'll see the process of massive switching. So पैकेट स्विचिंग ट्रीट्स ईच मैसेज एज एन इंडिविजुअल यूनिट. ठीक है, तो पैकेट स्विचिंग में जो एंटायर मैसेज है दैट कैन बी डिवाइडेड इनटू द डिफरेंट पैकेट्स, एंड दीज इंडिविजुअल यूनिट्स और पैकेट्स विल बी ट्रांसमिटेड फ्रॉम सेंडर टुवर्ड्स द रिसीवर. So before sending the message, the sender nodes add the destination address to the message. So before sending these packets, the sender will add the destination address into the header. So it is then delivered entirely to the next intermediate switching node. So the intermediate node stores the message in its entirety. So check for transmission error, inspect the destination address, and then deliver to the next node. So in message switching, the intermediate nodes, these are blue circles, are the intermediate switching nodes. So in that, first the message will be stored, then this intermediate node also checks the transmission error and inspects the destination address, means record the destination IP address, and then it delivered to the next node. The process will continue till the message reaches to the destination. So that is the simple working process of this message switching. Then we'll take the one of the example so that the working will be clear to you. So here we take one example. It consists of a sender or the transmitter, or we can say that the machine A is there, and second one the machine B is there, or it can be a receiver, and the sender will send a message to this receiver, so that can be transmitted through these intermediate switching nodes towards the receiver. So this intermediate switching node will receive this message, then it will check the transmission error in that, or it can inspect the destination address of this message, and then it will transmit it to the next node. So in switching mode or in switching node, the incoming message is not discarded if the required outgoing circuit is busy. Suppose this intermediate node or next intermediate node is busy, then this node will store this message in its buffer, and when this node, suppose this node is 3, so node number 3 is busy, so at that time this node 2 will store it this message 1 in its buffer, and when this node 3 will be free, at that time this node 2 will send this message towards the node 3, like that. So it is stored in a queue for that route and then retransmit when the required route is available. So this is called as a store and forward network. So message switching basically uses the store and forward network. ठीक है, तो जिस तरह से पैकेट स्विचिंग में ये फैसिलिटी अवेलेबल नहीं है, सो इन मैसेज स्विचिंग व्हेन द नोड इज़ बिजी it will store that message, and when the node is free, then it will transmit the message toward that node. So that can be a simple working process of this message switching. Then we'll see some of the advantages and disadvantages of this message switching. So we start with the advantages. First is sharing of communication channel ensures the better bandwidth usage. Second one, it reduces the network congestion due to stored and forward method. Any switching node can store the message till the network is available. So that is the main advantage of this message switching, in which the stored and forward method is used. Whenever the message or that message can be transmitted from sender to the receiver, so it will travel through this intermediate node. These intermediate nodes are busy at that time, that message will be stored in the intermediate node, and after that the node is free, it can be transferred. Next one, broadcasting message requires much less bandwidth than the circuit switching. Next one, messages of unlimited sizes can be set. So in message switching, the message of unlimited size can also be sent from sender towards the receiver easily. Next one, it doesn't have to deal with the out of order packets or loss of packet as in पैकेट स्विचिंग. तो हमने जिस तरह से देखा कि पैकेट स्विचिंग में देयर इज़ अ प्रॉब्लम ऑफ लॉस ऑफ पैकेट्स इन द नेटवर्क, और द पैकेट्स विल बी arrive at the receiver that is out of order because it takes the different paths. So that is not happen within this message switching technique. Then we'll see the disadvantages. So in order to store many messages of unlimited sizes, each intermediate switching node requires a large storage capacity. तो जैसे हमने देखा कि मैसेज स्विचिंग is based on the store and forward method. So these intermediate nodes requires the buffer or the memory to store the message packets. If these unlimited sizes of message will be sent, so this memory capacity of these intermediate nodes are goes on increasing. So that is one of the disadvantage of this message switching technique. Next one, stored and forward method introduce the delay at each switching node. This renders it unsuitable for real time application. तो जैसे हमने देखा कि इंटरमीडिएट नोड में मैसेज क्या होता है, स्टोर होता है, एंड व्हेन द नेक्स्ट लिंक विल बी और नेक्स्ट नोड विल बी फ्री, एट दैट टाइम इट विल transmitted. So that renders a delay or adds the delay. So that's why this message switching is unsuitable for real time application. So these are the some advantages and disadvantages of message switching. So that will end this part, which is a switching. So in which we study the circuit switching, packet switching and the message switching techniques. Then we'll see the part D of unit second, which is the introduction of data link layer, that is DLL. Then first we'll take the introduction of this data link layer. So we already know that this data link layer is a second layer of this OSI layered model. So this layer is one of the most complicated layer and has a complex functionalities and liabilities. So data link layer hides the details of the underlying hardware and represent itself to the upper layer as a medium to communicate. So data link layer works in between two hosts which are directly connected in some sense. So the direct connection could be point to point or broadcast. Okay. So system on broadcast network are said to be on the same link. So data layer link is responsible for converting the data stream to the signal bit by bit and to send that over the underlying hardware. So that is the main responsibility of this data link layer. तो उसके नाम में ये data link. So it will convert the stream or the signal into the bits and bit by bit data will be sent over the hardware. So at the receiving end, data link layer picks up the data from the hardware which are in the form of electrical signal and assembles them into the recognizable frame format and hands over to the upper layer. Okay. So at the receiver end, this data link layer picks up the data from the hardware which are in the form of electrical signals and assembles that received signal into the recognizable frame format, means in appropriate formats, and hands over to the upper layers. So there are two layers in this data link layer, which is a logical link control and media access control, that is MAC. Then we'll see the functionalities of this data link layer. So data link layer makes the difficult task on behalf of this upper layer. Then we'll summarize these different functions of data link layer. So first function is framing, in which data link layer takes the packets from the network layer and encapsulate them into the frames. तो फ्रेमिंग में डेटा लिंक लेयर क्या करता है कि पैकेट नेटवर्क लेयर से रिसीव करके उसके बाद उसको एक सुटेबल फॉर्म में encapsulate करता है, that is in the form of frame, and then it sends these frames bit by bit towards the receiver, and at the receiver end the data link layer picks up the signals from the hardware and assembles them into the frame. ठीक है. तो डेटा लिंक लेयर फ्रेमिंग में नेटवर्क लेयर से जो भी पैकेट्स है वो रिसीव करके उन्हें फ्रेम फॉर्मेट में एनकैप्सुलेट करता है, एंड दीज फ्रेम्स आर transmitted towards the receiver, and at the receiver end this data link layer will pick up these signals and assembles them into the suitable form. So that is the one of the function of this data link layer in framing. Second function will be the addressing. So data link layer provides the two-layer hardware addressing mechanism. So hardware address is assumed to be unique on the link. It is encoded into the hardware at the time of manufacturing. So this data link layer has a two hardware addressing mechanism. That hardware address is assumed to be unique on a individual link, and then it is encoded into the hardware at the time of manufacturing. Then third functionality of DLL is synchronization. When the data frames are to be sent on the link, both machines must be synchronized in order to transfer to takes place. तो जैसे हमने देखा कि there is a synchronization between the sender and receiver. ओके, जिस तरह से हमने सर्किट स्विचिंग एंड पैकेट स्विचिंग में देखा. सो इन सर्किट स्विचिंग फर्स्ट द कनेक्शन विल बी एस्टेब्लिश बिटवीन सेंडर एंड रिसीवर. सो दे एक्सचेंज सम डेटा for authentication purpose. So that type of synchronization is also the functionality of this data link layer, and after that the data will be transferred between sender and the receiver. Next functionality is error control. Sometimes signal may be encounter a problem, means error in transition, and the bits are flips, means change. So these errors are detected and attempted to recover the actual data bits. So it also provides the error reporting mechanism to the sender. Means sometimes in a network they encounter a problem in transition of these packets, और इन दैट द बीट्स आर फ्लिप, मीन्स वहाँ पे जो बीट्स है, सपोज यहाँ पे 4 बिट का मैसेज सेंड किया है विच इज़ 1010, बट एट द रिसीवर एंड इट इज़ रिसीव एज 1110, मीन्स दिस 0 कैन बी ट्रांसफर्ड एज अ 1. सो दिस बीट्स आर चेंज, सो दैट एनकाउंटर अ एरर. तो यहाँ पे एरर रिसीव हुआ है, एंड देन the data link layer will report this type of errors to the sender, and after that the sender will retransmit that frame again. So next type of functionality is the flow control. The station on the same link may have the different speed or capacity, means हम जो data send कर रहे हैं between sender towards the receiver, so this sender machine and the receiver machines are suppose a different or operated at the different speed, and its capacity is also different. So at that time the flow control of the this sending machine, means the packet sent by this sender is also a flow control mechanism. So this data link layer ensures the flow control that enables both the machine exchange the data on the same speed. Means suppose sender will send the data at the 10 kbps and the receiver will be receive the data at the rate of 5 kbps, so that will mismatch. ठीक है, तो इस कंडीशन में क्या होगा, सेंडर जो डेटा सेंड करेगा वो फास्टली सेंड करेगा, बट एट द रिसीवर दैट डेटा विल बी अवेलेबल एट द स्लोअर स्पीड. सो दैट इज़ नॉट हैपन. सो दैट इज़ द फंक्शनलिटी ऑफ डेटा लिंक लेयर that ensures that the sender and receiver has a flow control of the data to be exchanged. So that is also a functionality of this data link layer. And last one is the multi access. When the host on the shared machine or link tries to transfer the data, it has a high probability of collision. Or data link layer provides the mechanism such as the CSMA CD to equip capability of accessing a shared media among the multiple system. So when the host or sender will be shared the data through the link and it will transfer the data, so it has a high probability of collision. मीन्स यहाँ पे क्या होगा, जो भी पैकेट सेंड हो रहा है, ठीक है, so they will coincide or collide with each other. So at that time there is a error. So this data link layer provides a mechanism called as a CSMA CD. ठीक है, तो जिसका हमें डिटेल करना स्टडी करना है आने वाले लेक्चर्स में. ठीक है, सो दैट CSMA एंड CD means collision detection. Okay, so this type of functionalities are also available in data link layer. So these are the some of the main functionalities of data link layer or services offered by the data link layer. तो आज का ये वीडियो लेक्चर हम यही एंड करते हैं. नेक्स्ट वीडियो लेक्चर में हम टाइप्स ऑफ एरर का डिटेल स्टडी करेंगे. सो थैंक यू.